Okay, so we're going to do part of chapter 6. We're going to start with section 6.3. 6.1 and 6.2 are really just things that I don't think you're ever going to see, and it's showing you like really long ways of doing things that a calculator will do for you. So we're just going to stick with the basic matrix things and the ones that are the most simple. Okay, so we're starting with 6.3. We're going to do basic matrix operations. So all we're going to do is basically add, subtract, and multiply by a scalar, and a scalar is just a single number. Tomorrow we'll finish up this section. We'll multiply the matrices by each other, and then we'll move on to 6.4 on Wednesday. Okay, so first of all, a matrix is a rectangular array of numbers, and then the dimensions of the matrix are the number of rows by the number of columns. So if I'm asking you to give the dimensions, then if you look at this, it's how many rows does it have by how many columns does it have. So we have a 3 by 3 there. For this next one, how many rows? So 2. And how many columns? 3. Alright, people get confused about rows and columns, and sometimes I have to stop and think really hard. So remember that rows is how many across, and columns is how many standing up and down. Alright. So, in order for two matrices to be equal, all of the elements have to be equal. So each thing in a matrix is considered an element. So these are both 2 by 2. They're both a 2 by 2, 2 rows, 2 columns. So they could be equal, provided that each of the elements is equal. So if this is equal to this, and this is equal to this, and this equals this, and this equals this, then it's going to be equal matrix. They're going to be equivalent matrices. Alright, so they're trying to say, I want you to make these equal matrices. Figure out what x and y and z have to be the variables. So we know that x is going to have to equal to 12. We know that y plus 3 would have to equal to 5, so that means that y would have to be 2. We know that 2z would have to equal 6, so that means z is going to be 3. And 8 is equal to 8. So in order for these to be equal, we have to have x is 12, y is 2, and z is 3. And you're done. So there'll be something like that on your homework. They should be pretty easy. Alright, so find the indicated matrix. So to add and subtract matrices, you're just going to add or subtract things that are in the same place. And to multiply by a scalar, you're just going to take your matrix and multiply all of the pieces by the number on the outside. So we're going to do all of those things at one time because they're pretty easy. Alright, so for me to do 3a minus 2b, if I write that with the actual matrix in the place of a, and the actual matrix in the place of b, then it's almost an order of operations. We're going to multiply by the scalar, and it just distributes and multiplies to everything in there. So this would be negative 6, 9, 0, 3. And this would not need to be a 2 there. I'm going to keep the minus and distribute just a regular old 2. If you wanted to make this plus and distribute negative 2, that would work also. Alright, so we're going to get negative 16, negative 2, negative 10, negative 8. Alright, so now we have subtraction. So we're going to subtract things that are in the same place. So we're going to do 6 minus negative 16. So it'd be negative 6 plus, I just pointed at something and you can't see it, sorry. Negative 6, this makes plus 16. So I'm going to write that down just to make sure that you follow. So negative 6, this makes plus 16. So it's really, I need a little more space. It's really going to be, what, 10? My brain knows what I want to do, but your brain has not seen matrices before more than likely, so let me put in all the pieces. Okay, so now we're going to do 9 minus negative 2. So 9 minus negative 2, that's 9 plus 2, so 11. Then we have 0 minus negative 10, which is positive 10. And then we have 3 minus negative 8, which is 11. All right, so we can solve a matrix equation using kind of the same concept as solving a regular equation and using those adding and multiplying and subtracting skills. All right, so again, first of all, this is just a plain old variable x. If it was a capital X, it could represent a matrix, but it's not. So we're going to have this. We want to do 5 times matrix A. And that's equal to matrix B. All right, so just like if it was a regular equation, whoa, let me figure that out. Okay, if it was a regular equation, then you would multiply these and then subtract this term and then divide by the 2. That's how you get x by itself. Like if it just said 2x plus 5 times 7 is equal to 12. You would multiply these, subtract the 35, and divide by the 2. All right, so is my math good? That is not good. This is definitely a 2. Sorry. All right, which makes this a 2. All right, so, but you understand the steps. So we're going to follow the same steps. We're going to multiply this 5 by this whole matrix. So we have 2x plus the matrix, negative 15, 35, 10, negative 45, 25, 0, equal to the matrix, negative 5, negative 1, 0, 0, 3, negative 4. And in order to add or subtract matrices, they have to have the exact same dimensions because you have to have element for element. So if you ever run across like a 2 by 2 and a 3 by 3 and they're telling you to add or subtract, you're not going to be able to do that. So keep that in mind. All right, so I don't want to write things like over and over and over again when I don't need to, so make sure you're listening. I'm going to subtract this on both sides. Okay, so I'm going to subtract this one over here. So exact same matrix. And I'm subtracting it from the end of this one. Move this out of the way so it's not confusing. To get a new matrix here. So we will have 2x is equal to, and then whatever we get here. Alright, so I'm going to try to do this one in my head, so let's see if we follow. Negative 5 minus negative 15, so negative 5 plus 15 is 10. Negative 1 minus 35 would be negative 36. 0 minus 10 is negative 10. 0 minus negative 45 would be positive 45. 3 minus 25 would be negative 22. And negative 4 minus 0 is negative 4. Okay, so we want to divide by 2. Well, we don't really divide with matrices, but we know that if we multiply by a half, that's the same thing as divide by 2. That still gives me just plain old x. I need to erase just that. Okay. So we have x on the side, and over here, we're going to multiply by a half. So all of the elements here just get cut in half. So it's at 18. This would be negative 5. This would be 26. 27, no, 22.5, I don't know what I was thinking. This would be 11, and this would be -2. All right. I believe that's our last example. Yes. All right, so going back here, remember that your dimensions have to match to add or subtract. And that's really it. You add things in the same place, subtract things in the same place. If it's not a 2x3 and a 2x3, then you're not going to be able to do it. If it's a 2x3 and a 3x3, there's going to be too many numbers and you're not going to be able to add or subtract. All right, so this is your assignment. Let me know if you have any questions.